Alright, so this is some logarithm review. Let's start off remembering how to graph logarithms. The key is you're going to make yourself a table of values like this, a little t-chart, alright, x, y. Now the thing about logs is, for logs, this is where we start with the y values, and then we find the x values. Okay? So considering we're going to start with the parent function, which goes y equals log base 4 of x. That's what we're starting with. We can always start with the same y values. -2, -1, 0, 1, and 2. We'll always use those same y values. Am I going to wind up needing a third column? Sometimes we need a third column. Only when there's an a value, if there's a number in front. Since there is no number in front, 2 columns will suffice on this one. Okay, now here's how we get the x values. What we have to do is convert. We have to transform this equation into that other form. This is log form. Remember, we used to be able to switch this to exponent form. And the way we did that was, it was all about the base. We always started with the base. So the base is 4, so I'll bring that down. These other two things, the y and the x, they switch places, okay? So that means the x is going to wind up over here on the left, and the y is going to wind up over here on the right, but it's going to become the exponent. So that's how we transform from log form to exponent form. Yeah, the -2 will happen last when we do our transformation, where we either will move it up, down, left, or right, depending. But we do that at the end. First we graph the skeleton, and then we slide it over. So we're just doing the parent function now. Excellent question. So for these x's, I'm going to use this little formula then. And of course, that formula is 4 to the y power. So that means right here I'm doing 4 squared. So what's that? That's going to be 16. And then I've got 4 to the 1 power, which of course is just 4. Then I've got 4 to the 0 power. What's that? 1. That's 1. Anything to the 0 power is 1. Now, for these other ones, I mean, I could do it, 4 to the -1 power, 4 to the -2 power. But let's talk shortcuts. The top two are always going to be the reciprocals of the bottom two. So I don't really think about it too hard. I see the 4, and I know this one's going to wind up being 1/4. I see the 16. I know this one's going to wind up being 1/16. They're always reciprocal, so you can do it so fast, so fast. Okay, now this is just a skeleton, all right? Like Emily pointed out, we have not handled the -2 part of the equation yet. So don't connect these dots when we put them. Just place them down, but don't connect them yet. All right, I like to do my skeletons in green, so I think I'll do that right now. So here I go. 1/16 is so close to 0 is basically 0. All right, so this is kind of like having 0, -2. So that's basically, I'm going to have a dot right here. All right, and then I have 1/4, -1. So that's going to be like her. I feel like I should zoom in a little. All right, and then I have 1, 0, and then 4, 1, and then 16, 2 is too far off the graph to do anything about it, so I'm not going to worry about it. So I've got these 4 points that I can work with. Okay, now I'm going to do the shift. Remember, if I have something happening inside the parentheses, is this up, down, left, or right? It's to the right, okay? Anything in here is either left or right, and that's the one that's kind of the opposite of what you would normally think. So minus is actually to the right, okay? So that's what I'm going to do. I'm going to take each one of these points and move them to the right by 2 units. So this one is going to end up here, and this one will be here, this one will be here, and this one will be here. All right, so those are the 4 points I'm going to use. Don't forget, logarithm functions have an asymptote. All right, is it vertical or horizontal? Yeah, logarithms have that vertical asymptote. It used to be at the y-axis, all right, for the parent function. but we've shifted everything to the right too. So that includes the asymptote. So please understand that we're going to have this asymptote over here at 2, vertical line at 2. Draw it as a dotted line, please. Whoa. Okay, so there's the asymptote. And then you'll just connect the dots as best you can. I lost a point. Wait, all right, it got distorted for a second there, but now it's fixed. So just draw your curve through there as best you can. So it's going to be like this, something like this. All right. Down this side, it's basically going to trace the asymptote. So in your mind, you have to know that it's getting really close to the asymptote, but it doesn't really touch the asymptote. But it's going to look like it. You can't avoid it. It's microscopically close, and the ink is thick. So when you draw it, just go ahead and trace the asymptote. But mentally know that they don't touch. Mathematically, they don't touch. So that's it. That's how you graph it. Any questions right there? All right, in addition to that, we're supposed to say the domain and the range and the asymptote and the x-intercept. Okay, so let's go. So the domain, it's not negative infinity to positive infinity. See how it starts from the asymptote? So the asymptote is at 2. So the domain will be from 2 to infinity. Why did I put a round parenthesis at 2 instead of a bracket like I often do? Because it doesn't really touch the asymptote. So you're always going to put a round on the asymptote. No eating in class, Scully. That's your only warning. Emily already had her warning, so she's good to go. For the range goes from bottom to top. So that's going to be negative infinity to positive infinity for that range. Okay, the x-intercept is right here. It's the 1, 0 that got shifted. So now, no, I lied. The x-intercept is this 3, 0. All right, that's it. Any questions on number 1? Question? You're right. I almost forgot the asymptote. So, vertical lines are always x equals a number. So in this case, x equals 2 is the asymptote. All right, let's do another one of these. So let's graph one more log function. So again, anytime we're graphing logs, we are going to make a t-chart. Yeah, this time we're going to wind up needing a third column. In fact, I probably should leave myself more space than that. Move it over here.
Is this one going to be like 3?
I see that we have an a value multiplying in the front. Whenever that happens, that's when we need a third column. Okay? So anyway, we're going to start with those same y values. -2, -1, 0, 1, and 2. The parent function is y equals log base 1/3 of x. Okay? Erica, put it on my desk, sweetheart. So we need to transform this into exponent form. So I'm going to start with that base of 1/3. Remember, when we transform, the y and the x here are going to switch sides. So the x is going to wind up over here, and the y is going to wind up there as the exponent. Okay, so this pink function is the one I will use to get the x values. So I'm doing 1/3 to the y power. Okay, so that means I'm doing 1/3 to the -2 power and 1/3 to the negative 1 power, and 1/3 to the 0 power, and so on. 1/3 to the 1 power, 1/3 to the 2 power. All right, I'm going to start from the bottom because it's just easier for me to think about. If I do 1/3 squared, can you tell me what that's going to be?
1/9.
That's just going to be 1/9. All right, I'm just squaring the top and the bottom. All right, if I do 1/3 to the 1 power, that's just going to be 1/3. 1/3 to the 0 power is 1. Now remember what I said about a shortcut? What's an easy way to get these last two values? They're just going to wind up being the reciprocals of these. So instead of 1/3, it'll be 3. Instead of 1/9, it'll be 9. See how easy that is? Yeah. Okay? And we need to do a times the y column. So the third column is going to be, so the a value is 3. All right, so I'm doing 3y here. So that's going to make this -6 and -3 and 0 and 3 and 6. All right, did I lose anyone just then? Right, yeah, ay, so 3 times y. All right, once I have the third column, then I can forget about the middle column and use this instead. All right, so this is just going to be the skeleton that I'm doing right now. Sean Emil, head up, eyes open, brother, pay attention. Okay, so 1/9 is so small that it's basically going to be like 0. So it's kind of like having 0,6 happening right now, okay? So this is like 0,6 right there. 1/3, 3. All right, so it's 1/3, 3 would be like about here. 1, 0 would be here. And then 3, -3 would be right here. And then 9, -6 would be right here. Okay? So I have all 5 of those points. Now it's time to move them. What am I going to do because of this this +4 here on the end? That's going to be a transformation of up 4, translation up 4. So I'm going to move each one of these points, I'm going to move them up 4. So 1, 2, 3, 4. Okay, 1, 2, 3, 4. All right, so here are my points. Notice the asymptote is still the y-axis. So that's going to be the asymptote. So just go ahead and draw your graph as best you can. All right, so there it is. There's your graph. So the domain, what's the domain going to be, guys?
-infinity to infinity.
Oh, so close, bro.
Oh, it was 0.
0 to infinity, because the asymptote is 0. It will never touch or cross the y-axis. Okay, the range is going to be -infinity to infinity. Okay, what else did they ask us? Domain, range, asymptote. The asymptote is x equals 0. Vertical line at 0. Right, Sean Emil? Let me see those eyes, buddy. And then they ask us for the x-intercept, I do believe. All right, the x-intercept. You know, we don't know exactly what the x-intercept is. But we could estimate. It's like 4.5-ish. All right, that's just an estimate. That's the best we can do on that.